So the second half of section 4.6 is now adding or subtracting with mixed numbers, and they actually teach it two different ways, okay? So just like the 4.5 where we had two different methods of combining our complex fraction, we're going to have two different methods when it comes to adding mixed numbers. So what they do, and I might do it a little bit different than the book, but they just kind of line it up vertically like we would. So over here I'm going to write 2 1/6 plus 4 2/5, like that. So when it comes to adding mixed numbers, we have to add both parts. We need to start by adding the fractional part, and then if we need a carryover, we need a carryover. If not, we're going to add the 2 plus the 4. So what we have going on here is like a little baby section 4.4 going on, right? Remember 4.4 was adding fractions with unlike denominators, all right? So in order to add 1/6 with 2/5, what do we need for a common denominator? What's the smallest number that both 6 and 5 go into? 30, okay? Look at you guys just jump to that now, right? Those that don't feel as comfortable coming up with 30, again, these are smaller, so I would start with the multiple method where I start with 6, 5 doesn't go into 6, 6 times 2 is 12, 5 doesn't go into 12, and keep going until I got to 6 times 5, which is 30. So off to the side, I'm just going to write this as 30, and this is as 30. All right? So what we're going to do right to the side is write them as their equivalent fraction. So we ask ourselves, what did we multiply 6 by to get to 30? 5. So what do we need to multiply the top by? 5. So 5/30, guys, is equivalent to 1/6. What do we multiply 5 by to get to 30? 6. So we're going to multiply the top by 6, and we'll get 12. And again, I know I'm doing that quickly, but if you need to count, use your fingers, do tallies off to the side, that's fine. So at this point, we can kind of cross out our old fractions because we now have new fractions. But now that they have the same denominator, we can just add them. What's 5 plus 12? 17. So we have 17/30, which is a proper fraction, meaning it's not improper. We don't need to carry over or anything. And then we can just add 2 plus 4 and get 6. That's our answer, 6 17/30. Is that okay? So add the fraction part first. If you need to find a common denominator, do that. And then add the whole number part second. All right, let's just do the same thing over here. So we have 3 5/14 plus 2 6/7. We're on page 3 of our notes from last time. So I'm going to just cover up my whole numbers, and we're going to focus on these. We need to add 5/14 to 6/7. All right? So what's going to be a common denominator between 14 and 7? 14, right? Start with the bigger denominator, 14, and ask yourself, does a smaller denominator go into it? It does. So I'm still going to write this as 5/14 over here, so it's all kind of lined up the right way. And then what do we need to multiply 7 by to get to 14? 2. So what do we need to multiply the top by? 2, and you get 12. Is that okay? And I'm going to cross out my old fractions because these are the new ones that I'm dealing with. What's 5 plus 12? 17. So we'll have 17/14. And then what's 3 plus 2? 5. Okay. So right here, you think you have your answer. And you go and put it into my math lab, and they'll say, although your answer is correct, it's not completely simplified. Because in order to be a mixed number has a whole number and a proper fraction. And what do you notice about our fraction? It's improper. So we need to focus on him. He's more than 1, right? So what is 17/14? Do you remember how to change him back to a mixed number? We divide, right? So 17 divided by 14. How many times does 14 go into 17? 1 time, right? So what's your remainder between 17 and 14? 3. So this is really 1 3/14. You see what we have going on there, guys? So 17/14 is a little bit more than 1. So what we have going on is we have 1 3/14. We're just using the same notes from last time. Page 3 from the 4.7 notes. All right, so what we have is we have 5 and 1 3/14. But what is that going to be? Wait, oh, she's going. Is she leaving?
Yeah.
Oh. Does anybody want to run this to her? Oh, will you see, anybody see her later? Will you see her? I'll email her. Okay. Sorry, I thought she was just walking in late and needed these notes. Okay, so we have 5 and then 1 3/14. So what do we have total? Well, this is the only fraction part, so he can stay the fraction part, and we can just add the whole parts. So what's 5 plus 1? 6. So this is 6 3/14. All right.
How will we know when, how will I know when to do that?
It's when the bigger number is on top.
Okay.
When it's an improper fraction. So if you look up there, 17 over 30, 17 was smaller than 30. So that's called a proper fraction when the numerator is smaller. So you just, once you get done, ask yourself, does this look okay?
Okay.
And since 17 was bigger than 14, we knew we had to take that extra step.
See, my math, when I was doing this section, like this part, it was saying that, no, that's subtraction. Not
Yep. We'll have to like borrow and...
Yeah, because they said that to add one, which confused the crap out
I'll
of
show
me.
you, because you're borrowing 1, but then you have to turn it into a fraction.
Right.
Yep, we'll get there. That's with
Okay.
subtraction. Guys, here, they're just trying to scare you with the whole number, but that's okay. So we can have 12, and then 3 6/7, and 2 1/5 that we're going to add up. Okay? Do we really even need to worry about 12's fraction part? No, so we're not going to even worry about him. We'll add 12 later on when we do the whole numbers, but we're going to focus on just 6/7 and 1/5. So what's going to be the LCD between 7 and 5? 35, right? They're both prime numbers. They don't share any common factors. So the only number that they both go into is the product of the two numbers. So this is 35. And so as we move from one fraction to the next, we want to keep that ratio the same. So we just ask ourselves, what did we multiply 7 by to get to 35?
7.
Not 7. 5, right? We multiplied 7 by 5 to get to 35. Yep, sorry. So what do we multiply 6 by? We got to multiply him by 5. So our equivalent fraction is really 30 over 35. And then you go to the bottom. What do we multiply 5 by to get to 35? 7. So what are we going to multiply the top by? 7. So we get 7 over 35. And again, we can kind of cross out our old guys so we don't get confused. So 6/7 and 1/5 are still there. They're just in a different form. 30 over 35 and 7 over 35. And now that they have the same denominator, we can do the math. What's 30 plus 7? 37 over 35. Let that hang out as we come over here and add up our whole numbers. 2 plus 3 is 5, plus 2 is 7, and then only 1 in the 10 spot is a 1. So we have 17 and 37 over 35, and this kind of answers Caitlin's question. What do you notice about this fraction? It's an improper fraction, right? The bigger number's on top. So we're going to do 37 divided by 35. And some of you might not have to actually do division. If you know how far off you are by going in one time, that's going to be your answer there, okay? So how many times does 35 go into 37? Just once and barely, right? So we have one time, and then what's your remainder? 2. So this fraction is really equivalent to 1 and then 2/35, like that. So instead of keeping it as an improper fraction, we turned it into this mixed number. But we can't forget that that mixed number was with 17, right? So what's our final thing we have to do at the end? Just add them together, right? So the 37/35 is really this guy. So what do we end up with as our final answer? 18 and 2 over 35. Perfect, guys. And basically, have you guys ever been to a party where you have a bunch of pizzas, but then you want to like combine, get down to only a few boxes? That's what we're doing. It's like, okay, we had pizzas, but now we have a whole pizza and a couple slices left over. So really, we have one pizza and 2 35ths. So you usually just pile that on top, right? You know, that's what's happening is we're combining pieces from different pizzas. And at some point, sometimes we make a whole pizza and a little bit more, where sometimes we don't fill only about half the box. All right? So guys, subtraction is going to be kind of the same idea, but instead of getting this like improper fraction in the end, you kind of have to get an improper fraction in the beginning sometimes. So what we're going to have here is we're going to have 32 and 7/9, and we're going to take away 16 and 5/18. But we're going to do the exact same idea. We're going to worry about the subtraction of the fractions first. So I'm going to hide that. What if I just gave you the problem 7/9 minus 5/18? What do we need to do? We need to get an LCD. What's a common denominator that both 18 and 9 go into? 18, okay? So this is going to change to 18. I'm going to write him off to the side anyway, okay? This first guy, what do we do to 9 to get to 18? Multiplied by 2. So what do we need to do at the top? Multiply by 2. So we have 14 there. Is that okay? And then notice he was already at 18, so we don't need to change him. So what's he going to stay as? 5. And I'm going to get rid of my old fractions so they don't confuse me. So now we can do the math. 14 minus 5 is what? 9/18. And then we're going to come over here, not worry about this because that's what we just did right here. And we're just going to do borrow from our 3. So this is going to be 12 minus 6 is 6. 2 minus 1 is 16. And at the end, this is not an improper fraction, but what can we do to it? Simplify. And so that's what's going to get hard is like, always look at that fraction and question it. Is like an improper fraction that I need to change it into a proper fraction, or is it one that I can simplify? What does 9/18 simplify to? 1 over 2, right? And say you just don't even remember, do the same thing we've been doing, right? Look at that. Doesn't that look really funny? So 16 is my whole number, right? 9 splits up as 3 and 3. 18 splits up as 2 and 9, or 2 times 3 times 3. What do you notice? We can cross out both 3's. But what still remains on top when we do the crossing out? A 1. So 16 and 1/2 is our answer there. What? It's not too bad. It gets a little tricky when we have to start borrowing, though. Okay, that's what's we're gonna do over here, and this is the part that Stacy was talking about. All right, so let's do the same thing over here, and we're gonna have 9 and 7/15 take away 4 and 3/5. All right. So we're going to ignore our whole part for right now, so block it out and just look at 7/15 and 3/5. What is a common denominator that both 5 and 15 go into? 15. They're being nice to us, right? Like every denominator, LCD has been one of the denominators, I feel like. Here's 15, here's 15, okay? Did we change this denominator at all up here? No, so we're not going to change the top. It's going to stay a 7. Did we change this denominator? Yes. What do we do to 5 to get over to 15? Multiplied by what? 3. So we're going to multiply the top by 3 and we get 9. Cross out your old fractions. Now this is where it gets a little wishy-washy. You're like, what the heck is happening, right? So can you do 7 minus 9? When we're doing fractions, we're not going to do like negatives, like go into negatives or anything. So we have to borrow, all right? So who are we going to borrow from? The 9. Does everybody agree that when you borrow from the 9, you're taking 1 away? Okay, so let's start with that. Let's borrow from a 9 and he becomes an 8. All right, so now what do we have? We have 1 and 7/15, right? We had 7/15, but then we took away a 1. But does that help us? No, because we still have this whole idea of how am I taking 9 away? Well, let's change it to an improper fraction because we should be able to do that. So let's change this to an improper. Is everybody okay why that's a 1 and 7/15?
No, I don't understand. Why do we borrow from the 9 again?
Because we can't take 7 minus 9.
Okay.
Is that okay? So whenever your bigger numbers on the bottom, 7 minus 9, you start getting to like negatives. So you're like, I can't do that. Like in normal subtraction, 7 minus 9, you'd have to borrow from the 9, right? So you borrow from the 9 and he goes down to an 8. And what'd you borrow? A 1. So now you have a whole pizza and 7/15 of a pizza. Okay? But, yep. No, because we're borrowing a whole pizza, okay? So we have to say, well, in order to borrow a whole pizza, he needs to be cut in the same amount of slices. He needs to be cut into 15 slices. So really, this is what the book's trying to tell you. You borrowed 15 out of 15 slices. I say, just write it like that and then change it into improper fraction, because you guys know how to do that really easily, right? How do we change this to an improper fraction? 15 times 1, 15, plus 7 is 22 over 15. That is now our new guy. Okay? How the book teaches it is they say, you borrowed a whole pizza, and that whole pizza was cut into 15 slices, so you have 15 more slices. So 15 plus 7 is 22. Okay? Can we do 22 minus 9? Yes. Do it on your fingers. What do we have? 22 take away 9 is 13, right? 13 fifteenths. And then what's 8 take away 4? 4. Go back to your fraction. Is it an improper fraction? No. Does it need to be reduced? No. So 4 and 3/15. So I'm going to walk you through that again, okay? So I think you're all good with the initial setup and the initial changing them into LCDs, right? And we get to this point where we're like 7 minus 9, we can't do that. So we need to borrow from the 9. When you borrow, you're always taking away 1, okay? So since we're borrowing 1 from the 9, he reduced to an 8, and we got a whole pizza from him. But we still don't know how to do the math with this mixed number and this fraction. So we said, well, we could do it if it was just over 15 by itself. So what's the next step? Change it to an improper fraction. 15 times 1 is 15. 15 plus 7 is 22 fifteenths. So that means we have a pizza and some more slices, but we have 22 total slices, and now we're taking away 9. So we have 13 slices left. Does that kind of make a little bit more sense, Stacy?
Yeah.
And like I said, some of you will automatically be able to just say, okay, my denominator is 15, so I'm grabbing 15 more slices because I'm grabbing a whole pizza, and just add that to the numerator to get 22. That's fine.
It's weird because they put, like, whatever you borrow.
15 over 15?
It was like 1 plus 8. Or
Oh,
what,
yeah, no,
like
I
8 plus 1 over 7/15.
Yeah.
Like, what?
Nope.
That's where I got confused.
Yeah, we're just making it kind of just, like I said, we want to make whole pizzas. Let's move pieces around. All right. This one's kind of interesting because it's kind of the same concept, all right? So we have 25, take away 10 and 2/9. We don't have a fraction part here, but we need to take away a fraction part. So guess what we need to do again? We need to borrow. So what's 25 going to go to? 24, and we're going to borrow 1. But what's 1 take away 2/9? Some of you can just do that in your head, or why not get an LCD? How can we write 1 over 9? No, because you're saying 1 is the same thing as 1/9 of a pizza, right? How do you show a whole pizza? 9 over 9, right? Anytime you need to write a whole number, 1, it's just whatever that denominator is. So we borrowed 1. We borrowed a whole pizza. But in order to know how many slices are going to be left, let's cut them into the right amount of slices, right? So I borrowed a whole pizza, but there's 9 full slices there. So now we can do the math. What's 9 take away 2? 7/9, okay? We had a whole pizza cut into 9 slices, and then we took 2 slices away, so we have 7 slices left. And then over here, you can do the normal math. What's 4 minus 0? 4. What's 2 minus 1? 1. And then stop and ask yourself, do I need to do anything more with this fraction? No, because 1, it's not an improper, and 2, it's already reduced because 7's a prime number and doesn't cancel out with anything. So 14 and 7/9 is our answer. Let me talk that one over again. We need to do a fraction part minus 2/9, but we didn't have a fraction part. So again, we're borrowing 1 from 25. So 25 is changing to a 24. So we borrowed 1, but we still can't do 1 minus 2/9. We need to make him a fraction. So how do you write 1 as a fraction with 9 as a denominator? You multiply by 9 on the bottom, you multiply by 9 on the top, right? So 9/9 is 1, 9 take away 2 is 7, and you go from there. That's all the more they show you. What do you guys think? We'll practice with it, okay, with our worksheets. So in order to practice a little bit more, what do we have going on? They just have like 2 word problems. So on example D, it's using the same math we've done the first half of this lesson, but with word problems. So let's see what's going on. It says, the measurement around the trunk of a tree just below the shoulder height is called its girth. The largest known American beech tree in the United States has a girth of 23 1/4 feet. The largest known sugar maple tree in the U.S. has a girth of 19 5/12 feet. How much larger is the girth of the largest known beech tree compared to that of the sugar maple. Since we're comparing how much larger, you subtract, right? Compare, subtract, compare, subtract. Always take the bigger one, 23 1/4, minus the smaller one, 19 5/12. All right? Cover up your little whole parts, and let's just focus on the subtraction. Can I do 1/4 minus 5/12 as is? No. What do I need? An LCD, right? So what do we need to change our denominator to? 12. Are you guys okay with that? Start with the biggest denominator, 12, and ask yourself, does the second denominator go into it? And it does. All right. What did we multiply 4 by to get to 12? 3. So what are we going to multiply this by? 3. So you get 3/12. Is that okay? And then do we change this denominator at all? No, so we don't have to change the numerator. Cross out your old fraction so you don't get confused. All right? So we want to do 3/12 take away 5/12. Can we do it? No. So what are we going to need to do? Borrow, right? So who are we borrowing from? 23, right? So this 23 is going to change to a 22, and we're going to have 1 3/12. Is that okay? Because I borrowed 1 from him, so now I have a whole pizza and 3/12. But I still can't do that math. What does 1 3/12 change into? 15/12, right? So we say, I can't do the math with whole numbers and fractions, so what I'm going to do is I'm going to change him to an improper fraction. 12 times 1 is 12. 12 plus 3, this is 15/12, guys. And cross out all that junk, too. So it is kind of weird to walk in on, because you're just like, what have we been doing? I feel like we've been crossing out everything. All right? But now we can do the math. What's 15 take away 5? 10. So we have 10/12. And I know there's a bunch of crossing over going on here, but that's just all the fraction part, okay? 15 minus 5 is 10/12. So we can go all the way over here to the whole number part now, all right? Can you do 2 take away 9? No. So what are we going to have to do? Borrow 1 and then do 12 minus 9. What's 12 minus 9? 3. And then 1 minus 1 is 0, okay? When you get done, go back to your fraction. Is it an improper fraction? No, but what can we do with 10/12? We can simplify it. So again, I kind of do it weird. You don't have to do it this way if you don't want. So 10 splits up as 2 and 5, and then 12 splits up as 4, which is 2 and 2, into 3. Yes, ma'am.
On the part where you could, crossed out the 3 over on the 23,
Uh-huh.
I crossed out the whole thing.
Me 22, that's fine.
Okay, I still got the same.
Yep, it'll be absolutely. I did it that way up here with the 24 and 25. You can do either or. That's absolutely fine. As long as you know you're just taking one away and either reducing the 3 or the 23. Absolutely fine. So that 2 will cancel out and you guys are left with 5. 3 and 5, 6. What? Feet. So that means the difference between the two, it's weird to walk in. There's a lot going on there. I'll help you out with that. The difference between the two large trees is almost 4 feet difference there in girth. All right, let's look at the top of the last page here, example 16. We have the designer of women's clothing designs a women's dress that requires 3 1/7 yards of material. How many dresses can be made from 44-yard bolt of material? So what they're doing is they're telling you a scenario how to make one dress, but then they have this much fabric. And so what they're going to do is they're going to divide the fabric into multiple dresses. So what math do we need to do? Divide, okay? So we're going to write this as 44 divided by 3 1/7. So, guys, we're doing everything with fractions, so what's the first move I'm going to do to 44? Put it over 1. And before I even flip this, I need to change it into an improper fraction first. So this is what we did on Monday at the end of class. So 7 times 3 is 21. 21 plus 1 is 22/7. All right, so all I've done so far is rewritten my whole number of 44 over 1. And I've changed my mixed number to an improper fraction. All right, how do we divide? The first number stays the same, and then what happens? You flip the second, so this is going to be 7 over 22. And again, you guys might be getting to a point where you can start canceling right here, but I always just break it down, okay? What is 44? 4 times 11, right? But how does 4 split up? 2 and 2. So here's our 4 and here's our 11. Do you guys see 44 there? 2 times 2 is 4. 4 times 11 is 44. 7's prime. Woohoo! Celebrate the small things. Then you come down here. 1, we'll just leave him alone. And then how does 22 split up? 2 and 11. So what can we cancel out? 11's for sure. And then I heard the other one. What's the other thing? 1, 2. Is that all right? So then we're left with 2 times 7, or 14 on top. What's the only thing on the bottom? 1. So what's our answer? 14 dresses. So with her 44-yard bolt and them only taking 3 1/7, that's a tiny dress. 3 1/7 yards, because you have to go front and back. They can make 14 dresses with that.
So, I got a question.